Okay, example 3. Shirley wants to buy a new cell phone. She researches the cell phone she's considering and finds the following data on its longevity in years. So there's a bunch of data for how long cell phones lasted, and it is sorted conveniently for us in numerical order. Question, does the data approximate a normal distribution? Well, that seems like a really simple question, but it's actually got a lot of work you need to do it, to determine the answer. So criteria for normal distribution, the first thing we need to know is if it's symmetrical. So we need to graph it to see if it's symmetrical. So let's do that. So we're going to start with some basic stats. So the first thing we need to do, first thing you pretty much always do is n. So what's the n? How many data points are there? Well, it's arranged 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 5 times 10 or 50 data points. We need to know the standard, or the mean, sorry. We need to know the mean. So we're just going to do that in our calculation, or in our calculators rather. So the mean is 2.526, and I totally invite you and encourage you to pause the video and check that on your calculator. Make sure you know how to do that. Make sure my answers are right, because you know I make mistakes. We need to know the standard deviation, which is 0.482. I just want to back up 1 second and say, yes, we could do the n in the calculator as well, but that to me seems like it's an error checking thing, not a figure out the n. See what the n is on paper, like count them or figure out how many data points you have, and then when you do your calculations, make sure you have the right n, so you're making sure you've got the right number of data points in your calculator. Okay, the median. If we look at the median, they're sorted like down here, down here, down here. So half of it's going to be here. That's pretty easy. So the median is going to be halfway between 2.5 and 2.6. So the median equals 2.5 plus 2.6 divided by 2, which is 2.55. And the mode is the one that shows up most often, which is 2.7. We look at that, that's our mode right there, 2.7. So there we go, so 2.7. So one of our checks is, are the mean, median, and mode approximately equal? So we've got 2.526, 2.55, and 2.7. Yeah, they're approximately equal. Okay, and then there's a table down here. We can't graph it until we do a frequency table, so we need to do that. Unfortunately, I can't show you the whole thing on the screen at one time, but you've got the page in front of you, so you've got the data. So the range that what we're going to do, the ranges that we're going to set this time, we are going to base the intervals on mu and sigma, because we want to know for this criteria here of are the percentages correct within each standard deviation zone or whatever. We may as well use that as our intervals, and then we can check that in a way that makes sense. So the middle of my table here is 1, 2, 3, 4, 1, 2, 3, 4. Okay, so right here is going to be the mean, right here. So this range, the one above it, is going to be from mu minus sigma to mu. All right, so that when we graph this, I'm just going to do a real quick and dirty graph here. It's going to be, if this is our, that was a terrible quick and dirty. Even for quick and dirty, it was terrible. We should at least have the center in the middle. Like that. Okay, so this is our mean, and we want our first chunk to be between our mean and our mean minus 1 standard deviation. That's what this is. Okay, so from the mean minus 1 standard deviation to the mean. And so our numbers there is our mean. of 2.526 minus 0.482 is 2.044 minus, or sorry, 2, not minus, to 2.526. And then the next one, we're moving backwards in our graph. So like this line here is going to be the center of the graph, right? And we're moving to the left. So this one is going to end at our mean minus 1 standard deviation, and it's going to go all the way to our mean minus 2 standard deviations. So that's going to be like this chunk here from our mean to, from the mean minus 2 standard deviations to the mean minus 1 standard deviation. This number here is going to be the same, 2.044. And then if I subtract standard deviation of 0.482, this goes 1.562. And I'm just going to write in the rest of this for you. Maybe it helps if I write the word 2 instead of the dash there. And then I'm going to go down and start at the median again, or the mean, sorry. The mean to the mean plus 1 standard deviation, which is going to be 2.526 to 3.008. And then I've got the mean plus 2 standard, or plus 1 standard deviation. Mean plus 1 standard deviation to the mean plus 2 standard deviations, 3.008 to 3.490. Okay, so that's our intervals that we're going to use on the table. Okay, so now we need to go back to our data and look at the frequency. So how many of our data points are less than 1.08? So let's go back up. That would be up here. There are 0 that are less than 1.08. And how many are between there and 1.526? There would be 1 in there. How many are between there and 2.044? Oh, there's a bunch of them. 1, 2, 3, 4, 5, 6, 7. How many are between there and the mean, 2.526? That would be to here. That would go like that. So 5, 10, 15, 16, 17. How many are between there and 3.08, which is here, and 5, 10, 15, 16, 17, 18. Between there and 3.49 would go to here, which is 1, 2, 3, 4, 5, 6. And there was 1 and then 0. Okay, now let me add those up just to make sure I've included them all. So if I add this up, my sum there is 50, which is great. And then what percent of the data is each of those? Well, luckily, conveniently, since we have 50 data points, we just need to double it to get a percentage, to get it out of 50. So this is 0, 2, 14, 34, 36, 12, 2, and 0, and that should and does add up to 100. And then we're going to do the percentage. If the norm, if it was a normal distribution, what would we expect that chunk to be? So remember, going back, we had, if we split up our curve like this, and this is the mean, this should be 34, this should be 34, this should be 13.5, this should be 2.5, oh, actually 2.35, 2.35. 13.5, 2.35, and then some teeny number we don't ever worry about. Okay, so this one here should be 34%. This should be 34%. This should be 13.5%. This should be 2.35%. This should be 13.5%. This should be 2.35%. So that's pretty close, right? So that's so we're not doing this necessarily in the order, but yeah, about 68% here. It's 70%. That's pretty close. If we add up these ones, it's still, I don't know what it is, but it, like, the chunks of it are right, so that's pretty good, and that's pretty good. So that's pretty good for that. And now we just need to plot it so we can see if it's symmetrical or not. So I need to erase all of this because I'm going to need this space for writing in the things on my graph, which is much easier to do on paper than it is on this tablet. All right, so the middle of my graph, which is right here, this is my mean, and it is 2.526. So remember, that number is how long does the calculators last. So half of the average length of survival is 2.526 years. And then I'm going to divide this up so that every 2.5 grids is a standard deviation. And I eventually figured out that if I label it like this, instead of trying to put all the labels on one line, so this is going to be mu plus 1 standard deviation, which is 3.008. And this is mu plus 2 sigma, which is 3.490. And this one is mu plus 3 sigma, which is 3.972. And then going backwards, I have one here, and one here, and one here. So this is mu. It does not like me drawing that. It thinks I'm drawing a circle. Mu minus sigma, which is 2.044, and mu minus 2 sigma, which is 1.562, and mu minus 3 sigma, 1.08. And we didn't have any outside of that range, so we don't have to worry about that. And our frequency, our frequency is, the highest frequency we have is 18, so we're going to make this graph go up to 20. So this is going to be 0, this is 10, this is 20. I need to write in that this is the frequency, and I have this written on mine along the side here, but I can't write sideways on this. So this is longevity in years. And in our range, in our interval from, we're starting from 1.08 to 1.562, so our frequency in here was 1, so I'm going to, each of these is 2, so I've got to do, there's one. I had one phone that crapped out, oops, between a year and a half-ish. And then between a year and a half-ish and 2 years, I had 7. So 2, 4, 6, 7, that comes up to here. And then we had 17, so 10, 12, 14, 16, 17. Oops, and then the next interval was 18. And again, I do expect you to be using a ruler for this. And then the next interval had 6 and then 1. So 2, 4, 6 is right here. And then 1. Okay, so is it symmetrical? Yeah, that's actually pretty symmetrical. And is it bell-shaped? Yes, it's high in the middle and it tapers off to near 0 at the edges. So that's really good. So let's go back. Did we actually answer our question? Does the data approximate a normal distribution? Yes, that is our actual answer. Now, on a quiz or a test, of course, you can't just say yes or no. You have to show all of this work to justify your answer. You can't just say yes or no. You have to justify it, say why you believe that that's the case. Okay? And then there's a question down at the bottom that says, if Shirley purchases this cell phone, what is the likelihood that it will last for more than 3 years? So that's going to be, we've got this 3.008, which is pretty darn close to 3 years. I think we can use that data point. So what percentage of the cell phones survived more than that? Well, we can't just, we're looking for a likelihood, not a thing. So what we have to do is we can't actually determine, I'm going to change pen color here. We can't actually determine directly how many cell phones are up here, but we can determine how many cell phones are to the left of that, because we know that this is the mean, so 50% are that way. And because we're assuming that it's a natural or a standard, a normal distribution, sorry, this chunk here is 34%, right? So we can subtract that amount from 100%, and that will leave us with where the green arrow is to the right of 3.008. So what I'm going to write down here is 3 years. This is the answer that I would be looking for. 3 years is approximately at our mean plus 1 standard deviation. So we can do 100. Actually, let me just write down the actual what we did first, and then we'll do the calculation. So subtract percent expected to fail. Sorry, percent expected to fail by then from 100%. So what we have is 100 minus 50 plus 34, which equals 16%. So there's 16% that we would expect to be to the right of that 3-year line. Okay. All right, that is it for lesson S.3, and I'll be back soon with lesson 4. Take care.